Alrighty, 0.6, linear inequalities in one variable. Alright, so for part A, write an inequality that represents the interval and state whether the interval is bounded or unbounded. Okay, first of all, this is interval notation. And to give you a visual, let's graph this. So I'm starting at -5. It includes -5. And I'm going to infinity, positive infinity. Alright, so describing that using an inequality, we would have x is greater than -5, but it includes -5, so it's also equal. Alright, that's my inequality. And it goes forever in one direction. It doesn't stop, so this would be unbounded. Alright, on to example 2. Write an interval that represents the inequality. State whether the interval is bounded or unbounded. Okay, same deal. So let's use a visual representation here. Less than 7. So I'm going to use parentheses because it doesn't include 7. And there shouldn't be a negative there. Okay. And I'm going to the left. Alright, so using interval notation, where am I starting from? Well, I'm going over here to -infinity, and then I end right here at 7. Alright, but it does not include 7, so parentheses. Now with infinity, you will always use parentheses. Okay, and so there's my interval notation. And it goes forever in one direction to the left, so this one is also bounded, or sorry, unbounded. Alright, next example. Solve the inequality and sketch the solution on the row number line. Okay, so let's just isolate x. X is less than -4. And we're starting at -4 here. I'm going to the left. And I'm using a parentheses because it does not include -4. Alright, and that's it. For part B, just subtract 7. X is less than or equal to 5. So we're at 5 and it's less than, so I'm going to the left. And this time I'm using a bracket because there's an equal sign there. It includes 5. Alright, that's all there is to that example. On to the next. Okay, absolute value inequalities are really easy to work with. You just have to remember a couple rules. Alright, so here for absolute value, I have the positive case and I have the negative case. When I'm working with the negative case, I flip the sign. Alright, and we don't have to do any other work besides that. Since we started with greater, then I'm going to use this principle here, greater, meaning I connect these with an or. And so when I graph these inequalities on the same number line, I simply want to look at where the graphs are covering the number line. Okay, so the graphs cover what on the number line? Because I'm concerned about everything that's covered on the number line. So it's everything less than -4 and everything greater than 4. And that's what I have right above here. So that's my solution. Alright, going on to part B. Same deal as before. Okay, you first have to isolate the absolute value, which we have here, and then set up the positive case and the negative case. You also have to answer the question of how are these inequalities connected, by an and or an or. Well, we go back to the inequality when we isolated the absolute value, and we look at the inequality sign, and since it's less than, you want to think less than. Okay, so they're connected by an and. All right, and when we graph, that's when it's important to take into consideration the and. All right, so let's isolate x for both of these. Subtract 1. 2x over 3 is less than or equal to 0. Multiply by 3. Negative 2x is less than or equal to 0. Divide by negative 2. X is less than or equal to 0. All right, the other one, we got negative 2x over 3 is greater than or equal to negative 2 times 3. Negative 2x is greater than or equal to negative 6. Divide by negative 2, and x is greater than or equal to, well, it should be greater than or equal to. Caught myself there. Extra credit for Mr. H. All right. Now I need to graph these on the number line. So I have x is less than or equal to 0. Okay. But it's not less than or equal. It's greater than or equal to. All right, caught myself there again. Extra credit for me again. All right, so using brackets here, here's my number line going to the right. And then x is less than or equal to 3, so use brackets once again, going to the left. Actually, let me use a different color here. Okay. Now, since the inequalities are connected by an and, you are concerned about where the graphs overlap. Now, where do the graphs overlap? Well, the overlapping starts at 0, and then it goes all the way to 3, and includes 3. So that's your solution, all right, the red area. So it starts at 0, it ends at 3, my variable is x, and both inequalities always point, well, they always point to the left. Okay. All right, and that's the standard. Whenever you're writing out a compound inequality, you want to make sure both inequality signs are pointed to the left. Just think Beyonce. Moving on to the next example. Find the intervals on the real number line for which the radicand is non-negative. Okay, so meaning when you take the radical of this quantity, it can't be negative. So if it can't be negative, that means it must be positive, or 0. So 3 minus x then has to be greater than or equal to 0. Why? Because this has to be positive, which means it's greater than or equal to 0. That's the only way you could take the square root of it. Okay, so now I isolate the variable. Divide by negative 1. Okay, x is less than or equal to 3. I graph it. Less than, going to the left. And since it's equal to, I'm going to use a bracket. That's all there is for that. All right, here I have the fourth root, but just like the square root, all right, for the fourth root, you can only take the fourth root of a quantity that is not negative. So same deal here, 6x plus 15 has to be greater than or equal to 0. So I just isolate x. All right, x is less than or equal to negative 5 over 2. Just simplifying that. All right, and then I have negative 5 over 2, which is negative 2.5. And I'm going to the right. And I will be using a bracket once again, since it includes negative 5 over 2. All right, that's all there is to it. Begin the lesson at the bottom of the web page. Make sure to ask for help if you need any.